Appreciate you signing on today for another one of our webinars in our asset management series we've been doing this year. Today we have Mark Fiorito with us from the Trimble Energy Group, and to kind of review some of the capabilities and changes that have happened recently with GasOps and the ability to manage your natural gas system. A couple reminders, the session will be recorded, with the idea is that you don't have to scramble and take a lot of the notes. We'll send the recording out later tomorrow probably, or the following day, and that way you'll have that information as well, and then you can forward that on to your colleagues as well if you desire. Everyone is muted at the moment. Feel free to use the chat window to send your questions in. I know Mark has a couple of his colleagues on the webinar with us as well that can answer those questions probably during the session, but then we'll make certain that we do some answers at the end, or answer your questions at the end as well. Thanks everyone for your time, and Mark, I'm going to turn it over to you.
Fantastic. Thank you, York, for that introduction, and thank you everybody for taking time out of your day to join us to learn a little bit about Trimble Unity GasOps. And so as we get started, I wanted to provide an agenda. We'll do an overview more for our utilities and public administration group, because I presume most people here know who Trimble is, but you may not know about our utilities group, which energy is a part of. And then we're going to do a Unity GasOps overview, and then we'll dig into some demonstration aspects. And these are the topics that we'll really cover with that demonstration. And then at the end, we'll have a Q&A. If you do have any questions along the way, feel free to log those in through the chat window as York indicated. So let's get started. So who is Trimble? Trimble is a global leader in positioning and integrated technology solutions across a multitude of industries and markets. Founded in 1978, we were really the early pioneer in the development of GPS for the military. Since then, we've expanded and evolved our commercial applications from military to expanded positioning solutions. We've added laser and optical measurement technologies, and we use these capabilities to move this into more productive applications. And we think about machine control or machine guidance. Those are through partnerships, as an example with Caterpillar. So if you've seen these bulldozers or road graders as an example, with these 2-meter range poles on either side of the blade, the GPS on top is going to be Trimble. We have a strong history of annual growth. Last year was about $3.26 billion in revenue, and we invest about 13% of that back into R&D. And we're organized into dedicated industry units that focus on the specific needs of each market and the customer. So utilities and public administration, my group and the energy group is focused on natural gas and electric solutions. As we dig deeper into this utilities and public administration division at Trimble, our portfolio of digital asset and infrastructure solutions address all of the utilities: gas, electric, water, wastewater, and even local government. With our solutions, these organizations make decisions that are based on accurate data through predictive models and analytics. These solutions really provide this pathway to intelligent asset and infrastructure management, and we address the business workflows as we see here. So we think of them as building blocks, really. So thus the Lego analogy here. So mapping and data collection, that's typically what organizations know Trimble as. Enterprise asset and work management, we're combining these two components today. Permitting, planning, and design, we have tool sets for that. Network and distribution management, remote monitoring and IoT, which we're gonna dig into a little bit today, and then leading up to the constituent engagement and analytics. Through that, our solutions support every phase of the utility life cycle: design, build, operate. You got to plan it and design it, to the engineering aspect and construction, and then the operation and maintenance of it. And that allows organizations to analyze and optimize the assets, because that's really what we're looking to do, right? We want to get more bang for buck. We want to create longer life for our assets. So as our utility sector continues to grow, and build out our solution portfolio, we generally do that through two ways, either acquisition or both, or organically. Late last year, we acquired CityWorks, which is the leading enterprise asset management, work and compliance management company. And it's a GIS-centric system that allows you to fully leverage the power of your GIS and the analytics. And so that becomes important because we'll see here in just a minute, we're talking about where we sit in that with respect to Unity GasOps, and even CityWorks is this ecosystem for compliance. Real quick on CityWorks, they've got about 700 customers in North America and over 40,000 users, and they really help utilities in three buckets, from managing infrastructure and development to managing the compliance, which is where we sit in the natural gas space, especially with all the regulations. And then a secondary component to that would be the risk analysis aspect, and then this lifecycle asset management, all the way to permitting and code enforcement. So CityWorks is really rounding out this compliance lifecycle. Our utility focus for natural gas is really an end-to-end tool set for operators. So regulatory compliance and safety, standardizing field data collection processes, and then a platform, having a mobile platform for the entire utility, from new construction and replacement to legacy pipe and asset data collection, even incorporating 811 tickets, various types of inspections, leak survey, the work management, and even outage and incident management with our gas OMS. So as I mentioned just a minute ago, this gas compliance ecosystem, and our solutions fit into that world, and we actually have our own ecosystem. As an example, from a regulatory perspective and compliance, and this is very pertinent to what we're going to talk about today. Late September, PHMSA released an advisory bulletin on pipeline safety about overpressurization of your mains on the low pressure gas distribution. And so this is part of where we sit in this scenario in helping to reduce the potential for overpressurized mains, but also having this one platform that will address digital as-built, so tracking traceability, leak survey, and then these other compliance-based inspections that have to be done annually or every 24 months, not to exceed 27. And even the pressure monitoring and managing your incidents and outages. We support the three fundamental systems. You have system of engagement, system of record, and system of insight. The system of engagement, which is where our solutions on the right fit. So the Unity GasOps is really in these three primary categories. The data collection and digital as-builting, smart leak surveying and inspections, and then this asset management and IoT. And those are the three functions we're going to focus on today. But we also have our augmented reality solution, which is Trimble Site Vision for utilities, and our gas OMS for managing outages and incidents. As a whole, Trimble is addressing the natural gas utilities like we've never done before, and safety is at the very top of our list. Our solutions help break down these organizational silos to facilitate operational efficiency. We compile and aggregate data from these disparate systems and provide the mobility tools to the largest part of your workforce, which is your field crews, construction, inspectors. So now let's dig into a little bit about Unity GasOps. What is it? What does it do? Trimble Unity GasOps is the software solution for natural gas operators. You want GIS mapping for new construction, existing assets, redlining? We've got that. Work management for asset maintenance, inspections and repairs? Got that too. IoT and remote monitoring for real-time operational awareness? That's also a piece of the Trimble Unity GasOps portfolio. It is the single platform for smart gas management and analytics. It's a GIS-centric cloud and mobile software which offers a suite of applications and tool sets to support smart gas management efforts. So the product really focuses on the workflows and the business process improvement, and it has the added benefit of better information for decision making and regulatory compliance. It's built on Esri technology, so there's a seamless integration with your Esri GIS, and I presume most, if not everybody here, uses Esri as their GIS. The software also consists of two components: a web application, which is used mainly by office supervisors and dispatchers, where they plan, dispatch, and manage work. And then there's the mobile component, so the app that runs on your mobile device. And it's really built with the field technician in mind. So we kind of built it from the field back into the office. It's got a simple user interface, and it's got action-driven workflows. And all of this provides the tools that are needed for the field technician to improve their productivity in the field and streamline that data collection process. It is operating system agnostic, so it doesn't care if you use a Windows Surface tablet, an iPhone, or an iPad, or any Android phone or tablet. Additionally, it works offline, so if you've got poor internet connectivity or no internet connectivity, you still have full access to the GIS and the work assignments during these offline scenarios and emergencies when potentially you don't have cell networks for that connectivity. Trimble Unity GasOps is designed on this concept of apps and these configurable workflows. So the apps that are focused on these specific business processes, and they're targeted to a group of users that are responsible for these processes. So think about inspections. There's a laundry list of inspections. So you can have CP as an example, so your cathodic protection, and that only goes to your CP folks. They're only going to see what they're administered to see from an application perspective. And those workflows can be specific to cathodic protection as an example. And they're action driven. So basically what happens is it guides the user through the workflow, very similar to a wizard. By building intelligent data into these collection forms, it'll continue to help guide that technician. And that's really what streamlines this data collection process, is this intelligence to navigate the user along the way for the data they need to input. So with there's an app builder within Unity GasOps where users can create and manage their own apps through these guided step-by-step wizards, and it allows them to configure things such as the GIS data and layers that's going to be needed. What kind of background or base maps will they need? And then building the workflows. What if I do this, what needs to happen from a workflow perspective? So as I'm going through the inspection process, what's the first thing, second thing, etc. And then designing the data collection forms as far as putting the right things in the right order, so that when the user opens the form in the field, the first thing they need to enter is the first thing that would be reasonable for them to enter. It's got a simple user interface on the web portal, so it allows you to build and configure these intelligent forms. We think of it as intelligent forms because it's validations a lot of times, or as an example, a required field, right? It won't allow you to move on if this field is required. We can add conditional fields or questions. So there's a if and then statements. If the answer is yes, then provide them with these questions. If the answer is no, then provide them with these questions. You can add photos, small video clips, red line, various types of calculations. Ultimately, you can simplify these complex forms for field data collection through these built-in validations to ensure that the accuracy and the quality of the data collected is exactly what you need it to be. This is a snapshot of some of the mobile capabilities that are pertinent specific to the gas sector. So 1 and 2D barcode scanning. So this OQ, operator qualification badge scan. Today, we have partnered and are doing some work with EWM, but we also have the capability with organizations like ITS or MEA. Those are the three typical ones that we see in the US. But being able to scan that badge and get some information about that user. Are they qualified to do what they're doing? If not, don't let them do this. The F2897 standard for tracking and traceability. integration with our high accuracy GNSS receivers. I certainly hope and expect that would be expected from us, but out of the box, right? You don't have to do anything special except connect them. No different than you would a new set of earbuds. And then linking to our remote monitoring components to display these pressure recordings and various information from those devices in the field. Bluetooth connectivity to various types of sensors. We'll use pressure tests. We even connect to our own pressure test devices on the back end and add that to the work order so that everything that was within that work order would have that pressure test information. But there are other ones, Coleman Cirrus Sense as an example, and then electrofusion machines. Just a few of these are listed, the MTD, Centrifusion, Jackman, or even George Fisher. So for all you Esri ArcGIS users out there, this is where it really gets cool too, right? Because on the back end, we have native support for ArcGIS identity, web maps, and dashboards. Talked about the ability to work offline. What does this through generating this GIS cache? You can update the GIS based on what data you've collected. And then there can be QA, QC steps in the middle, and then you can have that go back directly into an ArcGIS database. And these are types of metadata that we can collect. So in terms of the forms, you can add various types of metadata from the GNSS devices. Accuracy, horizontal and or vertical, who collected it, what type of collection method was it? Did they GPS? Did they digitize? And then providing this, you collect the data, what do you do with it? Well, being able to provide insight for this operational efficiency through the ArcGIS platform. A lot of you have already invested a lot of dollars in this. So, with our technology, we allow you to create these maps and dashboards that work through Unity, but allow you to share these things across the organization. It also allows you to leverage your existing capabilities of the Esri ArcGIS platform. And then without having to do any development, it's already integrated based on the native Esri ArcGIS integration because the Unity GasOps platform is built on Esri technology. So now we're going to look at the three scenarios we're going to see in a demonstration aspect today. And so the first one is going to be data collection and digital as-built. Well, that's where we get into the tracking traceability, being able to support that. I think OQ really spans the globe in terms of whether it's data collection from a digital as-built, existing, any type of inspection, or even leak survey. So we'll see that in these as well. But ultimately, being able to capture the data that's going in the ground to a high degree of accuracy, being able to scan the barcode, and then validations on those data entry points so that you can streamline the data collection process and ultimately know that the data that's being collected is correct and accurate. The second one we're going to look at is what we call smart leak survey. And so what makes it smart? What makes it smart is not just dropping breadcrumbs, but being able to consume data from a leak detection device into that breadcrumb. So we drop a breadcrumb every second, and we can populate that with, as an example, a Heath DPIR. We can consume that data and drop populate the reading from that DPIR in every breadcrumb. Well, that allows defensible and traceable software or technology on the back end, because it's not just telling you where you went, but now you know what the reading of that breadcrumb was as they were walking along. So as the leak comes into fruition, by your leak detection device, we can automate some things to open up a collection form, or it can be manual, but the breadcrumb continues to track as well as populate with information. So that's really what makes this smart, being able to understand what we're doing on the back end and what the data was being gathered through that leak survey. And then the last thing we're going to look at is the IoT and remote monitoring. And I got a few more slides on this one because while this isn't a new concept, we do know that not all of our customers or even all the gas utilities in the US have network monitoring from end to end. And what we mean by that is putting them at regulator stations, at endpoints, at gate stations, So we can monitor the gas pressure on the endpoint. We can monitor it from the riser, from the regulator, in input and output, so multi-channel. Removing these paper chart recorders so you don't have to go out and investigate those. You can just pull the data. And so through the pressure monitoring aspect, I mean, it really starts with this sensor that monitors the pressure and flow and even ambient temperature. Ours uses the built-in LTE modem to transfer that information back to a server access to our Unity GasOps. And you can do that through the web portal or the mobile app. It also has a specific GPS location of where that asset is. Ultimately, it's the sensor that has the location, but you know what it's connected to and what asset it's connected to. So this will include hourly information on the pressures and flows, and then also alarms. So if you have a high, or a low pressure alarm, these things get broadcast out through text message, email, or both to the right people in the organization. So this is a use case of a customer that we have in the Northeast. They've got about 200 pressure monitoring devices. One is at every regulator station. Some are installed as flow meters for industrial customers, and they're at every endpoint. And this allows them to have full system visibility from a pressure and flow perspective. That's end to end. The driver for them was Hurricane Sandy. And what they were able to do was reduce the time, gas, and labor expense because they didn't have to go out and visit all these places, all these reg stations with these paper charts. They were able to identify AOCs that previously were unknown, and that helped them in prioritizing replacements and repairs. And then over time, they were able to build these trending reports. Well, that helped them identify areas of concern and plan for future scenarios. Another big key too was identify potential failures where they had no backup or loop feed. A few of the benefits for our remote gas pressure monitoring solution are reducing the risk of overpressurized mains. As I mentioned earlier, late September, we had a notification from PHMSA about overpressurized mains and reducing that risk. Identifying AOCs and providing data that's traceable, verifiable, and complete, which helps your DIMP requirements. And then better planning data versus paper, so you have the ability to chart and check out trends. And then the data at your fingertips, 24/7, 365. It's through accessing the web portal or the application on your mobile device. So now we've learned a little bit about what Unity GasOps is. Now we're going to dive into a Unity GasOps demonstration. We're going to cover the three topics that I just went over. For this, I'm going to hand this over to JD Cornelius, who is our product manager for Unity GasOps. JD, you are on the clock.
Thanks, Mark. I'm sharing my screen now here. So we got about 30 minutes here. We can kind of try and hit some high points about some of the different components of Unity GasOps that Mark was talking about previously. What we're looking at now is the Unity web portal, where we can see we have this ability to select these different workflow apps that we want to access. We're going to look at our GasMapper, gas leak inspection, and remote monitoring apps. But like Mark mentioned, is we can configure these workflow apps and really kind of key into the specific types of data and the specific workflows that you're trying to do out in the field, and then create these workflow apps that will complement that work out in the field to do that data. The key takeaway here from this is that we can also assign these workflow apps per user. So if you have guys in the field that are just doing leak inspection, they don't have to see all of these other workflows that may be from the remote monitoring side, or some valve inspection stuff or whatever. So we can tie these workflow apps to a user. We don't have time to get into details into everything, but we have part of the Unity web portal is the app builder, where we can manage and create these different apps. Mark also kind of gave some highlights of where we can manage and create these different smart forms or templates that we can use, and we can tie into the different map services and base maps to use for the field application from the web portal here. But if I go back into my app selector screen, and what we're going to open up first is just the we call our GasMapper, or think of this as the tracking and traceability data collection workflow app that we've created here. So when you have data that's captured out in the field through the Unity mobile platform or Unity mobile application, it will all sync back into this cloud portal first. And what we're looking at here is a list of all of the work orders that we have going on currently now in our system. And we can then filter on different statuses. I can look at only my open work orders or closed work orders or completed, how we want to define that. I can look at work orders as who they're assigned to individual users. And I can also base them off of priority, as well as we have the ability to define, some other filters and stuff here as well. But what we're looking at is this list of work orders on the left. This list of work orders could originate from an external work management system, and we're pushing them into the Unity platform to facilitate some of this data capture, or we can create them directly from the Unity web portal here as well. So if I was to just select one of these, this will zoom me into that location where this work order is, and it opens up the work order details. I can see any information that was captured by this work order, and we'll actually look at the mobile application and do some of this capture ourselves. But this is showing us all of the data that was captured in this particular work order. If I select one of these records, it kind of highlights it on the map there for me. I can see any of the attribute information that I populated, as well as any attachments that may have been associated with that particular work order. So work order creation is really easy, and this is kind of functionality is duplicated across the different workflow apps. So we'll use the same functionality in Leak Survey app or Regulator Inspection app. But essentially all we have to do is create a work order is we can just select some features that we want to work with, either by doing an attribute query or drawing a polygon to select those assets, and it gives me all of those existing assets here on my left that I can select from. Now we'll point out that these assets that we're looking at here are not a copy necessarily of the data that you guys have in your GIS system, but we're feeding Unity with those feature services out of the Esri platform, so that this data that we're looking at in Unity, both here through the web portal and through the field app, are feature services directly out of your GIS system. So we're not having to work with copies of the data or maintain multiple sets of those data. But I can then create a work order. I can give it some different information, and I can assign it to whoever I want to assign it to, and then it will sync down to their device. So we'll see this portal again as we look at some of the different workflows, but this is kind of the hub of how all of the workflows and forms get created, jobs get assigned, users are managed, and then jobs are assigned to those users to the field app. So if I minimize this, I've got the Unity mobile field app running on a little Samsung phone here, and we see that we kind of replicate that same view in the field mode, where you have, based off of the login and the permissions that you have access to these different workflow apps. So if I tap on the GasMapper Workflow App, this is the same workflow app that we were just looking at previously through the Unity web portal. I can see these are the list of work orders that have been assigned to me, to my user. If I open one of these work orders up, I have these workflow actions that I can progress through the workflow. This is a new one, or one that I've, not a new one that I've already opened. So I'm already in a particular status here, but once I'm inside of this work order, I could see all of the details that were added from the web portal. I could also make changes or edit any of this stuff that I need to on that work order details. So based off of the workflows that we've defined and the custom actions that we've set up, we can then start collecting asset data. Essentially, I could do that by just clicking this button here, and I'm choosing what type of data do I want to connect. These are forms that are user configurable. You know, these forms are configurable by you to capture whatever information it is that you're needing to capture out in the field. So I'm just going to start with a distribution pipe. And when I select that distribution pipe, it opens up this custom form that we've defined for it. What we see first is a summary of all the different components or different pieces of this form. So if I want to look at the feature info, I click over here, I can see this information or feature info about this asset. We can also move through the different pieces of the form through the tabs up here at the top. But we'll start with the geometry tab, and this is where we would use a GPS device to capture this information out in the field. I'm sitting here in my office, so I'm going to just use our digitize functionality to capture some information. When I first open this up, it zooms me to the location that we've defined for this work order. I can just pinch to zoom and drag it around as need to for my device to get where I need to be. Obviously, if we were connected to a GPS device, it would zoom to that location for us. So since I'm just in the digitize mode, I will just drop a vertice there, drop another vertice there to represent the line that I'm trying to capture. And I can hit this check mark, and I've captured all of this geometry information. Mark mentioned some GPS metadata. We can capture all of that metadata and populate it in this form as well. Moving through the next form, the next part of the form, we have a capability to capture this EWN badge, as was mentioned earlier. So all I got to do is tap my scan icon here, and I've got my badge here laying on my desk. I'm just going to scan that badge, and we can see that it automatically decodes that badge and populates the information that's provided to us. We were typically use this information to do some form validation and allow access to different parts of the form, you know, whether their user is qualified or not, or if it's expired.
Be careful.
Because this, I've got an older badge here. We need to get an updated one, but the expiration is already expired on it. So I'm just going to manually validate this badge. I can then move into the different parts of the form and filling stuff out. So I could fill out the asset type, whatever. Let's see, it's actually be plastic. We can select install methods. And we can list out any equipment used. So like Mark mentioned, the electrofusion machines, and we can create this as a drop-down list. So you can just pick and choose what equipment you may be using. We can define whether the equipment's calibrated, and we can validate all of these different forms. So if somebody says equipment calibrated no, we can end the rest of the form there, so you can't go on any further. We define life cycle status. Any of these fields, these are totally configurable by you guys, the user, to capture whatever information it is you want to about this particular asset. We can record some pressure information directly on the asset itself. We can also do that at the work order level. And then we also support, as was stated, the F2897 barcode. So I've got another barcode here at my desk. I keep this one taped to my laptop because we use it quite often. And I can scan that barcode, and we can see it automatically decode the coded values here from the barcode into all of the appropriate attributes. So in this case, it's a George Fisher's the manufacturer. It gives me the lot code and production date, which are some of the key attributes for the tracking and traceability side of everything. Tells me what the material is, what type it is. It's an electrofusion company, and it tells me the different size. In this case, we also have a metadata field where we can capture some other information directly on the asset. We also have the ability to add any attachments. So this is where if we wanted to capture a photo for the feature as we place it in, I'm just going to take a photo here of my messy desk. Capture that photo, and then that photo is stored with that asset in the system. If I tap add again, we can also capture videos, or if I want to choose from my camera gallery, maybe I have a PDF document on my device that I want to attach to this asset. We also have this ability to capture the map view. So what this does is it kind of just opens up the map view from where we are. If I had a GPS, it would zoom me in, and I could then capture that screenshot essentially of that map view. Then I have this ability to do some basic redlining on top of that image and save that screenshot of the map view and that red line that I've done, and it saves it as an attachment for that particular asset. Then when I'm done, I filled everything out, hit the check mark, and it takes me back to the work order details, and I can now see that I have this one gas distribution pipe that feature that I just collected. We can then move on to collect another asset. In this case, let's do a coupling, and we can see we have the same sort of form to fill out here for this particular device. Start with my geometry. Again, we would capture this from the GPS if we were connected, but I'm just going to use my map view to digitize this. We'll zoom back to where I was before, and I'm just going to place this coupling there at the end, hit the check mark. I could then move on to the next part of the form. In this case, we've got another EWN badge scan. Scan that badge again, it populates everything. If I look over here at feature info for this one, it's all blank, and that's because, again, of that validation that we were talking about. Because this badge is expired, it's not validating for me, so it's not letting me see any of that other information. So that's why I have this manual validation just for the demos. And now if I move back over into feature info, just tap feature info, now I can see I have all of that information is now available to me for me to fill out. So is it insulator device, yes or no? Set the life cycle status. These are the same similar kind of forms that we were filling out before. So if I go back to this equipment info tab here, I can select, I'm going to use electrofusion machine. I can populate the serial number for this, whatever it may be. And I can also capture any readings specifically from that electrofusion machine that we need to store into this feature, so that we have records of what that electrofusion machine was telling us. Things like the ambient temperature, how hot it had to heat up to get to the correct temperature to fuse the pipe like it's supposed to, and all that sort of stuff. We can also track any calibration info we need on this equipment. I'm just going to scan back here through my tabs up top and hit my barcode again. Just going to scan this same barcode that I use just to give an idea of how it works. Scan it, fills it all out automatically. You can see our metadata tab. Again, attachments. So I want to take a picture, add another photo here. Click OK, and then hit my check mark. And I've captured 2 forms very easily directly within this work order. If I tap this view all on the map, this will open up the map view for me from my device, and it will zoom me in and show me all of the different assets that I've collected as part of this particular work order. I can then, if I want to, I can actually get driving directions if I need to as part of this as well. So it will open up Google Maps for me here and try and route me from my location to where those assets are on the map if need be. And I'm just going to click back over here into Unity, and I'm going to hit my back button to get back into my work order, and just drag down, and I have now the workflow buttons available to me once I've collected everything that's part of this work order, I can then mark this work order as complete. It changes the status here on the device for me. Then the next time the application syncs, it will push all of that data back to the Unity Cloud portal that we were looking at previously. All right, any questions about tracking and traceability, as-built data collection? I'm going to move on and talk about leak survey a little bit now. I want to pull back up the Unity web portal here, and I'm going to change apps, and I'm going to go into a leak survey app that I have created. So in the leak survey application, we have the ability to connect to the manufacturer Heath, their DPIR leak detection device. So we make that connection to the DPIR device through the field application, and what it allows us to do is capture that leak reading information directly with the breadcrumb trail as we collect the breadcrumb trail, indicating where we have traveled, what we have done as part of that particular job. So the breadcrumb trail is not only the proof of what we did as a surveyor out in the field, we can also use that breadcrumb trail to then perform some spatial analysis, and we can mark pipe as being inspected and update values and all that kind of stuff with it as well, based off of spatial analysis of that breadcrumb trail. So back here in the Unity Work Management, I'm going to create a work order now that's going to represent some pieces of pipe that I need to inspect. Again, I'm just going to do this by drawing a simple polygon around things, but we can create these work orders again from a work management system and feed it in, or we can create them manually from the Unity web portal here as well. So I've drawn a simple polygon to select features, but we could also do a attribute selection here on the assets itself and say, show me all the pipe that hasn't been inspected since 2005 or whatever it may be, to get that selection set of assets. And then the application, once I have that polygon drawn, it gives me the available assets. I'm just going to select all of this distribution pipe, and I'm going to create a work order based off of that distribution pipe. So now I'll just type in some basic information about this work order. I can, again, these are configurable by you guys. Set the forms up how we need to. I'm in the North District here. Knows it's a leak detection type because of the app that it's in. The status is open, and I'm setting a priority. I'll set a priority for high, and I'll show you how that priority comes into play. Then I can search for a user that I want to assign this work order to. I can add any notes to it, and then we can set the location of the work order. And this is just kind of a general location of where this work order is, so that we can kind of zoom to that area when we open the work order up from the field app. If I scroll down through, and I can see all of the list of assets that are part of this work order, and I click create. And the Unity web portal here will show me these. This is my new JD Wheaton Test 45 work order that I just created. I can see the address that I set for that area, all of the details I've defined for it, and the list of associated assets that are there. What we see on the left-hand side, again, from that list of work orders, we color code this and give them the icons. So M are medium priority work orders, and the H is high priority. And if it doesn't have a priority set for it, we won't show it. But this is just another way that we can filter. So if I just only wanted to look at all of my medium priority work orders that I have set, I can set that filter, and I'm only looking at those particular work orders based off of that priority. So now if I come back to my device, I'm going to go back into my app selector, and I'm going to select my gas leak inspection. Now here's a work order that I had previously copied to my device just right before the meeting, so I would know I'd have something there. But if I come up here and click trigger sync, and I'm triggering this sync manually, we can set this up to where it happens automatically and in the background, so that users will automatically get any new jobs that's been assigned to them. And I've got several other workflow apps here, so it's syncing everything related to those workflow apps. So it's not just syncing this leak survey app, it's syncing everything. Again, I've got some remote monitoring groups assigned here for another app, but we can see it gives me this notification on the device that I've got one new work order, and it tells me it's a leak detection from the leak detection app. It's just, if we had work orders from other apps, it would tell me 5 new work orders, 1 from leak detection and 4 from the GasMapper app, that sort of thing. So I'm just going to dismiss that notification, and here is, if I tap on the this new job, this JD Wheaton test 45, I can see that based off of that custom workflow that I've created for this app, it's a brand new app. So the first thing I have to do is mark that it's in progress. So think of this as like not only accepting the job, but saying that you're starting to work on it. So I tap in progress, and then it opens up other actions to me that I can do different things with. So we see that I have all of the work order details that I had set up here before from the Unity mobile app. If I look over here, I can see these are all of the 50 different pieces of a gas pipe that I had associated to that work order. And we can customize these workflow apps so that it can automatically trigger the creation of, or the starting of that breadcrumb capture. But I'm gonna start mine manually. So I just go up here and start capture breadcrumb trail, and it tells me that position tracking has been enabled. And now if I click this button to look at my map view, and it zoomed me to the location of the map, I've actually got a little kind of GPS application running in the background that kind of fakes the GPS location, so that you guys can kind of see how the breadcrumb trail works. But this is me just moving through the, imagine this is me walking down the actual road here, and every point that we capture is a part of that breadcrumb trail, and we're able to, I'm not connected to a DPIR device, but if I was, I'd be able to look at that particular point and see what those that leak detection reading was from that point. We also, what we'll see here in a little bit, is at the end of this leak survey, I can, once I say I'm finished with this job, we take all of this breadcrumb data and we package it up and we store it as an attachment at this work order. So not only do we have like kind of a physical or a visible proof of where we were, but we store this breadcrumb file as a CSV file as an attachment, and it will have, for every point, it drops a lat long value in the file, as well as whatever that corresponding reading was from the DPIR device at that time. So here I am tracking my leak survey. I'm walking down, and my device goes off, and it tells me, it's detecting a leak. I can tap this button to record my leak, and it will then open up the custom form that I have set up to capture all the different leak information I need to. As always, we kind of start with a badge scan to validate. I can scan the barcode there, and it populates the information. And I'm just going to, again, manually validate because it's expired on me. And I can then move through the rest of the form. We've got some stuff set up, configured in this form, so it's automatically pulling information from the work order into the asset form, so we can automate some of this info. Then I can just move through here and start filling anything out that I want to, right? Put people's names in here, who the operator was, when the leak report date was. So it was reported today at say 10:35. Oops, should have been AM. 10:30 today at 10:35 a.m. I can set a location of the leak, right? It's a corner of North Street and South Street, right? So we can configure this however we want to capture information. This is just a form that one of our other customers was doing. We can capture who reported it, what their address was, a description of the leak. We can say whether inside or was it outside, who it was detected by, all that kind of stuff. Actually, who went out there and detected, that would be me, the user. We can define who it was dispatched to, anything it was assigned to. All right, so this is us trying to create a response to this leak that we're detecting. We can set the investigation, who it was investigated by, was it actually found, yes or no. We can see if I say yes, then this is another example of those conditional formattings. I define, when I said yes, it tells me to fill out some additional information based off of those values that I set. So it's right now it's just collecting near a building. Probable source is this service line that we see coming through here, and if we wanted to, we could grade this leak out if need be. We could also track any repairs that were made if we needed to, and then another feature that we have is the ability to add signatures for things. So I can, using my finger, just sign in here and save a signature. Whoops, I was supposed to select who that was. This is the foreman. I click save. And again, we can see the same sort of attachment functionality that we had before. And I think that's everything. I hit my check mark. I've now captured this leak form, right? We can see this leak form associated with it. And now if I click complete, it does some stuff in the background. And if I come back in here and look at this form again, we can see now we have an attachment. And this attachment is that CSV file that I was explaining. That is that breadcrumb file, essentially. So once we've done all of that data collection with the, represented by the breadcrumb, we can store all that breadcrumb data directly with the work order. And when we sync this work order back up to the Unity web portal, I'm able to look at it. I'm just going to just select a different one here, and I'll see it's got an attachment set to it. And just to kind of show you guys, well, I can't preview it here, but let me just download it real quick. Download this CSV file, and if I was to open it up, it shows me an entry for every breadcrumb point that was captured, a date and timestamp, the latitude and longitude. It gives me some accuracy information. And then if I was connected to my DPR device, it would show me the parts per million or percent gas. All right, so one of the other things that we wanted to show real quick was some of the remote monitoring functionality. So I'm just swapping over behind the scenes here to another Unity instance. All right, this is you see that's a notification that after it's synced, the work order had been removed. So let me copy this up to here and log in with, oops. Logging into another Unity instance that actually has some remote monitoring data to it. This is one of our gas customers that's using this to track. They've got these pressure monitors in place. Here's a little notification. You can see we notify customers if there's going to be planned maintenance. Apparently this Saturday, there's going to be some planned maintenance. So we try and be transparent and let everybody know. But if I was to select one of these units that we have here, I can zoom in. I can see this is, I'm looking at all of my GIS data in the back end in relation to this monitor. But I can see in this case, we've had several alarms go off on this particular device in the past couple of days. In this case, if I click that alarm, I can then view the alarm, and I can look at the alarm in conjunction to my pressure. So what we're seeing here at the top is essentially live pressure data from, well, it's a couple minutes old because it's got to sync across, but it's pressure data from today coming from that remote monitoring device out in the field. And we can see here where the pressure dropped. If I just try and zoom in a little bit here to that device, I can see where the pressure has dropped a little bit, and it's dropped enough that it's triggered an alarm. So we're also tracking those alarms at the bottom too as indicators. I can then, generate reports based off of this and export this out to, to different file formats or any kind of reporting that I want to do with it. So that's a real kind of brief highlight to some of the remote monitoring stuff that we're capable of doing, combining our remote monitoring IoT devices with the Trimble Unity GasOps platform. And this information is also available to us from the field device. So we have remote monitoring apps that we can access from the field, and we can see all of the same measurement data as well as alarming and all that kind of stuff for it. So if I slick back on here, I can look at my measurements and see all of the for a date range, and I can see all of the different measurements that are here that have made up this particular site. So we're actually tracking both of these. I don't know why the other one wasn't turned on. We're tracking an inlet and an outlet pressure. This is one of our multi-channel recorders that we have out there, so we can record several different sensor streams. Mark also mentioned temperature. You'll see a correlation between drop in temperature and pressure as well, but we still need to monitor it for anything that goes past any of those low alarm configurations.
And as those alarms hit, they will continue to send messages until the pressure rectifies itself or it's fixed by somebody doing something to it. And it'll also track the duration of that incident.
Yeah, I forgot to mention that. Obviously, we can do notifications on these alarms. So email notifications or text message notifications let you know when these alarm values hit. So here I've turned on those alarm visibility. We can see, correlate those pressure dips here from our inlet pressure where those alarm ranges were turned on as well. So today it's actually been a little bit longer duration for some stuff. And I was just talking with these guys the other day, and they said this has been very valuable for them to be able to use this to start analyzing their system and see where some problems are, identify where areas need to be addressed using these remote monitoring devices. So that very high level overview of some of the capabilities of Trimble Unity GasOps. We'll end it there. I think we might have a minute or two left for some questions if anybody has any. All right. If no questions, I will stop sharing my screen and turn it back over to Mark or York, whoever is up.
Thank you, JD and Mark. I think that went really well. I don't think there's any questions in the chat window, but if those in attendance, if you want to unmute yourself and ask a question, you're welcome to at this time. Great. Any parting comments, Mark?
No, just appreciate everybody's time today. I know we all have a full plate, so appreciate the time you spent with us. And if you have any questions that come up after the fact, you can always route them through York or your Duncan-Parnell representative, and they'll get those to us.
Great. Thank you so much, Mark. Thank you, JD. Everybody have a Merry Christmas, and we'll resume our webinar series in mid-January, so look for some information the first of the year. Thanks, everybody.